All right. Hello there, everybody. We are Group 12, and for our Hack Something project, we chose to do the topic of Wi-Fi Pineapple. Now, has a couple different names. You may refer to it as Wi-Fi Pineapple, Pineapple Wi-Fi, or Pineapple Router, or anything of the sort with the word pineapple in it when we're not talking about food. Okay, so to start off our presentation, my name is Ryan Schuett, and I'm going to be talking to you about the general information regarding this topic. Okay, so I'm sure you're asking yourself, what is a Pineapple router? What is Pineapple Wi-Fi? So what this is this is a system that acts as a middleman between users and Wi-Fi connections that those users want to connect to. So they'll attempt to connect to their choice of Wi-Fi, right? But instead of going directly there, they will get sidetracked, so to speak, right? And they will be prompted by the system. And they will be asked to log in, right? So this login could be either to Google, Facebook, any one of those popular websites that you use to log into other websites, right? Regardless, you're gonna have to give up some sort of personal information or some kind of thing like that just to get access to the Wi-Fi that you wouldn't normally have to give that information to get access to, right? Typically, these Wi-Fi pineapples are used by IT professionals to test the vulnerability of their networks. They do this so that way they could find any way that an attacker could get into their networks through any backdoors or whatnot. Okay, moving on to security risks. So Pineapple Wi-Fis have a high risk with high effectiveness, so to speak, right? So the way that this works is people hear and eavesdrop of other gossip and whatnot. It basically drives the consumerism part of the human brain to always have the fastest and newest thing. So for example, if you hear about a Wi-Fi with a higher speed, you're gonna try and connect to that regardless of the consequences, right? This is actually gonna be brought up later in an example, which will be brought up later. So as for the risk of this, it's a rather high risk given that everything on the network is now vulnerable and anyone can see what you're doing because you went through their system. So all internet activity would be included in this, and with that being said, this could easily break an organization or company if this data became public because, well, that information is not supposed to be out there in the first place. Okay, so one of the other things when it comes to accessibility, which is included in this security risk, Pineapple Wi-Fis are very easy to set up and they are also very cheap to acquire, right? You can buy a Pineapple router anywhere from $20 to $200, right? Whatever you want to pay or how easy or how powerful you want it to be, right? This makes it extremely dangerous because literally anyone can do this and get to all of this information. It doesn't take some special thing in order to make this happen. Okay, moving on to impact.
Hi, my name is Kinder, and I'll be going through the other parts of this slideshow. So we're going to go through with impact. In impact, we have found that it's actually low impact because most people won't even know that it's there, and they won't even think twice of what's happening. Once they go into the Wi-Fi, they immediately think they're all good and set. And most of the time, this is just used as an act of reconnaissance in which we're just spying on you. And the attack is not really directly to you because you won't even see it or you won't even feel it. And so most of the time, this goes unnoticed until someone says it out loud or someone made people aware that it's actually like a fake one. But most of the time, you won't even know it's there. For consequences, we have found that your personal information will be at risk. This will go from your login to your password, and sometimes, if you're not using a safe VPN, we might even be able to get your banking statements, your numbers, and your student numbers or your IDs. And last but not least is that your internet activity will be logged. With this much information, we can actually we can start stealing or becoming like you, like stealing, like, what was it called? Identity theft. And we're gonna do a real life example of this. It will be, we tested this out earlier this week, and we did it inside the fishbowl of UA. And we just created a fake hotspot. We made a hotspot called Campus Air 6 test. And this is a test in which we're gonna be using the latest Wi-Fi called Wi-Fi 6. And we just started talking to random students regarding it. And by the time we know, we actually have a 5 out of 8 who fully connected to it. And these 5 people, 4 of them are actually strangers. We never talked to them, and we never even interacted with them.
Okay. Okay, hello, my name's Kenneth, and I'll be doing the technical discussion part of this Hack Something project. And yeah, okay, let's get into it. So here's our topology of what we set up for this project. Here you can see that our Raspberry Pi is acting as a Pineapple router. So our Raspberry Pi is connected directly to an Ethernet port that emits a Wi-Fi signal. In this scenario, the Wi-Fi signal that we are emitting is called Starbucks 5G. Once a user is connected, we essentially give them an address from our pool of addresses from the DHCP. Another thing that happens when the user connects is that it creates a trunk that allows us to sniff whatever traffic they're doing, since they're technically going through our router to the internet. Another thing that's possible with our Raspberry Pi is using social engineering kit, we're able to do a number of different things. One thing is possibly directing them to a specific website. Another being changing the header of a website to make it actually look like they're on that website instead of just some sort of random IP address. Now I'll be going over why it exists. A better question is, why would it not exist? So when it comes to man in the middle, the Pineapple router basically modernizes the whole concept of the attack. If you think about the whole new trend of having Wi-Fi everywhere you go in public places, like if you consider like going to a restaurant, you have some sort of public Wi-Fi. The Pineapple router makes that a lot more accessible and easier to do. Or even if you think about the new trend of having Wi-Fi, like even in like the TTC train or popular roads that are used. Another reason why Pineapple router exists is, again, through the number of attacks you can do with it. If you consider the attack vector, which consists of 3 different things, like targeting the user, targeting the browser, and targeting the web, the Pineapple router just makes it easier. So, for instance, targeting the user it's basically making the user connect to our router, which is hence allowing us to snoop on their traffic. We're targeting the browser by maybe cloning or redirecting them to said website. And lastly, we're targeting the possible web app by gaining their credentials to said website.
Hello. Today I'll be going through our demonstration for our spoof Wi-Fi network. This is to be implemented in perhaps a place where you'd expect an open Wi-Fi network for customers or even for the potential house. So starting off, we have our service DNS mask. This is what's supplying our DHCP and some of our DNS resolution for our spoofed sites. And we're going to see how we've configured it. So we're going to go in and cat our configuration file. And as you can see, we have our interface WLAN0 along with our Google linked to our local address, as well as a backup DNS server. And lastly, we have some additional hosts configured in a different file. Lastly, our DHCP. This DHCP range is what will allow clients to dynamically get addresses. And next, we'll be looking into our additional host file. We decided to go with an alternate spelling for Google in case any unbeknownst customers tried accessing our spoof Wi-Fi network. So as you can see in our additional host file, we have our one record linking to google.com. Next, we'll go ahead and take a look at how we configured host APD. This is what has allowed us to create an access point with our device. And as you can see, the service has been activated. And next, we'll go in to our actual configuration file. Once again, we'll be using our wireless NIC in order to give the customers our Wi-Fi access. And as before, we're using our WLAN 0 network interface card, and our driver is the NL802.11. And lastly, we set an SSID of Starbucks, 5 gigahertz. And in order for access to be permitted, we wanted to forward all the traffic from our WLAN interface through our other WAN-facing NIC, which in this case happened to be our Ethernet 0 interface. So here we have two rules set up. One of them that takes all the inbound traffic from the Ethernet 0 and forwards it through the WLAN 0 interface, only where connections are established or related. And next, we're allowing any related, established, or new connections from the WLAN 0 interface out the Ethernet 0 interface. And next, we'll be looking at our custom template that we built for that the users will actually be accessing. So here you can see that it's quite a long template. This is something that we reused from the actual social engineering toolkit. We noticed that the social engineering toolkit's template was a great starting point. However, we wanted to alter it to better fit our use case. So next, we'll go into we're going to enumerate through our social engineering toolkit file structure, and we'll find where the templates have been kept. So they're in the SET /source/html/templates folder, and here we can see that there is the Google template as well as the other ones such as Java and Twitter. For this project, we took a copy of it and then we altered it such that when the user goes to log in and they submit the form, it'll actually forward them back to the Starbucks website. And also, we've altered it so that the landing page actually says, in order to access the Starbucks 5 gigahertz network, you have to sign in with your Google account. Just some small tweaks to make our template as believable as possible. Next, we're actually going to run the social engineering toolkit with our custom template. So here we want to use the social engineering attacks as well as the website attack vectors, and then we'll use the third option for credential harvesting. From here, we're going to select the option for the custom template, and the default address is correct. We're going to be using our local Raspberry Pi address. And then from here, we're going to specify the path of our site files. So we'll be entering our rogue portal from our home directory. And next, since it's just the single page, we're going to just take the first index.html file. And since we're creating a copy of google.com, we'll go ahead and add that in. And next, we're going to jump over to our device to make sure that connectivity is actually confirmed. All right, here we are on our mobile device, and as you can see, the Starbucks 5 gigahertz network did connect, and under the IP address, it looks like we have an address in our range, and we're going to set the DNS to automatic, and the default gateway has been set to our Raspberry Pi. So internet connectivity works, we can get to Google, and now we'll try our version of Google. Perfect. So now you can see, sign in with your Google account to experience the new Starbucks 5 gigahertz network. So here we'll put in some data that the social engineering toolkit will pick up. All right, and from here we're going to try signing in, and then our redirect does in fact take us back to our Starbucks website. And just to further confirm the connectivity, we're going to go to YouTube and just make sure that everything loads properly and in a timely manner. So it looks like it works well. All right, and hopping back over to the machine. All right, it looks like we have a couple of credentials entered in. So here's the first one, hello@goodmorning.com, password hello world. And to further this attack, one option is to actually do packet capturing. Since we are not only the wireless access point provider, but also the forwarder, we have full access to all the packets that are flowing through the device. So from here, we're going to go ahead and test out just a default TCP dump. And from here, you can see that the devices that are still connected are sending quite a bit of traffic through. And from here, we can filter it down. So we have our interface tag, and then another option is exporting all of the packets to an actual file. So here we're creating a file, our PCAP file, and then we're going to run the TCP dump command again with the W tag, allowing us to write directly to the file. With this, there's a whole slew of different tools that allows you to go in and actually analyze the data. This includes something like dsniff, which will actually go through all the data and pick out any plain text. That is the end of our demonstration. Thank you very much for watching, and we hope you enjoyed.
All right, so this is the end. It was nice talking to you guys. Thanks for listening. And here is our demo.